In problem number 4, we have 4 packages and 4 houses. And I guess we're assuming that each of these packages is supposed to be delivered to these 4 houses, but um, they're actually delivered randomly. The poor UPS driver must have had a long day, and he's not paying attention anymore, and he delivers these last 4 packages to 4 houses, and he just sort of delivered them randomly apparently. All right. So the question is, what is the probability that exactly two, all right, that's important, exactly 2 of them are delivered to the correct houses? All right, we're dealing with probability, so what's probability? Probability, okay, it's the number of desired outcomes over the number of possible outcomes, the total, total number of outcomes. Oops. All right. So let's start with the denominator, the total number of outcomes. Well, he's got 4 packages and 4 houses. So how many ways can he deliver the packages to these 4 houses? Well, he's got 4 choices. Let me write this out here though. Total number of outcomes. Alright, so he's got 4 choices for the first package, right? He's got 4 houses he could deliver it to. He chooses one at random, so he has 4 choices. Right, and then he's going to deliver the second package to one of the other 3 houses. So he has 3 choices for that. And he's got 2 houses left, so he's got 2 choices for the third package. And then finally, he's only got 1 house left, so he's just going to drop that one on the door. And there's no choice. Okay, so we end up with 4 factorial. Okay, that's just the definition of factorial. 4 times 3 times 2 times 1 ways to deliver those packages without any restrictions at all. So what is that? That's 12 times 2, which is 24 ways to deliver the packages. But we want to know how many ways, or well, actually, we want to know the probability that exactly 2 of them are going to be delivered to the correct houses. Okay, that's our desired outcomes. So let's take a look at that. Let me draw some houses here. We have 4 houses. Alright, and we'll number them 1, 2, 3, and 4. Okay, and we have 4 packages, so let's see. 1, 2, 3, and 4. 2, 3, and 4. Okay, so let's take a look at the combinations that we can find to deliver 2 of them correctly. So I guess what I mean by that is one case would be, we call it case 1, is 1 and 2 are delivered correctly. Case 2 could be 1 and 3 are delivered correctly. Alright. Case 3 could be 1 and 4 are delivered correctly. Alright, and that's all of the combinations that involve 1. So let's go on to case 4. Let's say we have 2 delivered correctly. We've already got 2 and 1, so 2 and 3 could be delivered correctly. Or 2 and 4 could be delivered correctly. Right, and then that's all the cases involving 2. And so 3 and 4 could be delivered correctly. And that's basically it. And you might notice that, so there's 6 ways that we could deliver these packages correctly. And and you might notice that that's just 4 choose 2, right? So it's 4 packages, and we choose 2 of them to deliver correctly, right? So that's just 4 times 3 over 2 times 1. Okay, and we get 6. Alright, so if you know combinations, you might have just done it that way. So there's 6 ways to deliver correctly, but we do have to think about what about, for example, in this case, where we delivered 1 and 2 correctly. Now, what about packages 3 and 4? Can we just deliver them randomly? And the answer is no, we can't really deliver them randomly because it says exactly 2. So if we are going to have exactly 2 packages delivered correctly, then 3 and 4 would have to be delivered incorrectly, right? So 4 would have to be delivered to 3, and 3 would have to be delivered to 4. So now if this had said at least 2, we'd have a different story, right? Because then we'd have 3 and 4 could be delivered 2 different ways. They could 3 could be delivered to 3, and 4 could be delivered to 4, or we'd have the opposite, 4 delivered to 3 and 3 delivered to 4. Okay, so then we'd have 2 ways to deliver the final packages. Okay, so we have to read carefully, and it says exactly 2. So packages 3 and 4 would have to be delivered incorrectly. Okay, and there's only one way to deliver them incorrectly. Okay, the same way here, we have 1 and 3 delivered correctly, but that means 2 and 4 would have to be delivered incorrectly. And there's only one way to do that, okay? So if this had said at least 2, then we'd have twice as many. We'd have 2 ways to deliver 1 and 2 correctly, because we'd have 1 and 2 delivered correctly, and then 3 and 4 delivered correctly, or 3 and 4 delivered incorrectly. Okay, but it does say exactly 2. So we only have one way to deliver the other 2 packages in each one of these cases. So we really don't have to worry about that. We just have one choice left for the remaining packages. Okay, so we end up with 6 ways to deliver the packages, to deliver exactly 2 packages correctly. All right, so that's so we have the numerator and the denominator now. So the probability is equal to 6 over 24, which is equal to 1/4. All right, and that's our answer.